And this question talks about ozonelesses. What is ozonelesses? Ozone is O3 gas and lesses means breaking down. So breaking an organic molecule using ozone is called ozonelesses. And let's see how can we ozonolize these compounds. You have pent-2-ene. 1, 2, 3, 4, 5. This is pent-2-ene. On ozonelysis, this is what that happens. You break the double bond. And what do you get? You should write it. Just separate them. Just put them a little far apart. And all you need to do is just attach oxygens here. What? Yes. That's all. Yes, that's all. What is this? You have to write IUPAC name. So this is 1, 2. This is ethanol. And 1, 2, 3. So this is propanol. Sadenal rahoge to whatever. Ethanol and propanol. Now, they have not mentioned whether this is oxidative ozonolysis or reductive. So I must write down the products of both the ozonolysses. If I have reductive ozonolysis, these are the products. In these cases, in case of reductive ozonolysis, what do? You add ozone and then follow it up by adding zinc dust. Then you would get ethanol and propanol, two aldehydes as the products. If you don't add a reducing agent like zinc dust, if you just add water, then this becomes oxidative ozonolysis, and in oxidative ozonolysis, the aldehydes, it's not that you will not obtain these aldehydes, but these aldehydes will not stop here. They would be further oxidized to carboxylic acid. So you would get ethanoic acid and you would get propanoic acid. This, my dears, is what you will obtain. Ethanoic and propanoic acids. The second compound in ozonolysis is 3,4-dimethyl hept-3-ene. 1, 2, 3, 4, 5, 6, 7. This is heptane. 1, 2, 3. 3,4-dimethyl hept-3-ene. This is the compound. Can we carry out its ozonolysis? That is very, very simple. You have learnt it. Just break this up. Ding, dang, ding. And just stretch it out a little like this. And then what do you need to do? Just attach O's here. Oh my God, these are ketones. Yes, they are ketones. And let me remind you, ketones are very difficult to oxidize. So maybe oxidative or maybe reductive. In both oxidative and reductive ozonolysis, these are the products only. Same products, there is no difference. Names 1, 2, 3, 4. 1, 2, 3, 4, 5. This is butanone. Or if you want to be stylish, 2-butanone. It is not necessary, but you can write it 2-butanone. And this is 2-pentanone. Why one? Because it is a ketone. We have 2-ethyl but-1-ene. But-1-ene and this 2-ethyl. Ethyl. Again, very simple. What do? Cut off the head like this. So I would obtain this and this. What is this? If I have reductive ozonolysis, I would obtain methanol or formaldehyde. This is CH2CO. Yeah, sorry, CH2 double bond O. And this is an aldehyde, of course. And this is, pentane 3-pentanone. Okay. And what about oxidative? If it is oxidative, please remember, 3-pentanone stays as it is. But if you have formaldehyde, Formaldehyde is very easily oxidized to formic acid. And usually acids are very difficult to oxidize. But there are two acids, two carboxylic acids which can be oxidized further. If I have HCOOH, formic acid, it gets oxidized to carbon dioxide. And if I have oxalic acid, H2C2O4, oxalic acid also gets oxidized to the normally acetic acid or ethanoic, propanoic, butanoic, all these acids stay very well as the products in oxidative ozonolysis, except two acids, 1 and 2. Formic and oxalic acids are oxidized to CO2. Now you may say that there is no oxalic acid here. I know there is no oxalic acid here, of course. This is extra information. It is not relevant in this question, but it may come handy in some other question. So in this case, you get 3-pentanone and CO2, and that very well is an exhaustive answer for this question. Write the IUPAC names of the products obtained by the ozonelesses of the following compounds. What do we have? We have 1-phenyl-but-1-ene. Now 1-phenyl-but-1-ene. What does that look like? 1-phenyl-but-1-ene, like this. 1, 2, 3, 4. How much is this? If you ozonolize this, what do you get? Well, we have this is what we get, my dears. This, of course, is a product of reductive ozonolysis. This is benzaldehyde, or IUPAC name would be benzene carbaldehyde. And this, of course, is 1, 2, 3. So this is propanal. Of course, these are the products of reductive ozonolysis. No, we want this to be oxidative. Well, let's do it again. If you have oxidative, then they would happily be oxidized further. How exactly? This becomes propanoic acid. This is R. And this becomes benzoic acid or benzene carboxylic acid. This is benzene carboxylic acid, aka, or also called, in short, benzoic acid. Benzoic acid is the common name, and benzene carboxylic acids, my dear, this is the IUPAC name.